Okay, this talk is about next level signals. And I'm Joseph, or on the internet I'm Rokojori. I'm a game and app dev from Berlin. I released an indie game called Dash Cup Kickers, which was an arcade soccer game. And currently I'm working on a library called Rokojori Action Library. This library is quite big. It covers a lot of things like shaders, game logic for third-person controllers, procedural asset generation. It has also a responsive UI, and also it covers more of tools and other things. In this talk, it will be about actions, and maybe you already know what it is about, but most people probably not. What is the problem, actually? The problem I had, maybe internet is working. Yeah, we have to do it without internet. I will just explain what was the problem. When I started creating my game, I had the problem that this was an arcade soccer game, very close to Mario Strikers before it actually came out again, and where you have a lot of shots and tricks and passes and a lot of things that you can do, and all of them need to be visualized by VFX. Also, in my plans for the game, I also wanted to make the effects that they have modifiers and other state effects that would even change all these kind of effects. So so the problem was for me, how do I develop all these varying effects and can basically combine them in a good way where I don't have to code everything in a very tight way. So I could basically use signals and events for getting when I have a pass or when I shoot, but what should I do with all the particle effects that I have and all the sound clips and everything needs to be launched? Should I use just one class that handles like a lot of things together, or should I use multiple classes that will be orchestrated somehow differently? And I tried actually a lot of those things to make it work, but what I was then deciding to, or what was the winner, is basically actions. And now you probably still don't know what an action is, and that's why I explain you what is not an action. With an action, I don't mean an input action that you can perform with your character. It's also not something that you can confuse with a state machine action. It's more closely that you can resemble with a C# action, like just a basic function. But in this talk, it will be about the Rokojori action, which is actually just a node with a trigger. So you can imagine you want to have a function and you want to have it also in your node tree. So what you do is basically you have one node, something that extends the node and has one function that you can call that will trigger something. It has no parameters in the definition or in its interface itself, but you would use the members as the parameters for the function. So instead passing them on the fly, you just use the members. I will explain later why, but for now, here's an example how it works. So this would be a play sound action, and there I would reference an audio stream player 3D, and would use this to trigger it so that it plays the sound. In the inspector, it would look like this. You have the exported player variable, and you could then just drag in some hit sound. Same for play particles, a function where you can reference the particles, and those particles will be started when the action is triggered. Okay, so you probably got the concept right now, and how do you use this in nodes? For instance, imagine you would write an enemy, and you want to have something like a signal when a hit occurs to the enemy. So what would you do? You would add an action, name it properly, like on hit, and then do your logic, something like you have a method called isHit, and then when this hit occurs, you basically trigger this function that you defined before. And you can see in this enemy example, I referenced the play hit sound action, which means like whenever this thing is hit, it will play a hit sound. This is all nice, but it would only play one action, so you would only be able to reference just one single thing that this thing would do. So the solution to this is creating an action list. This makes one action to execute multiple actions, and the action list itself allows you to execute multiple actions on two things. Either you pass an action array, so you pass them by reference, or you just trigger the direct children. And what you can see here is the setup of the enemy, which is then referencing an action list, and this just says, yeah, take my children and execute them. So in the hierarchy, it looks like this. You have then here the enemy with the action list, and then it plays the hit particles and the hit sound. So, this works very nice for a lot of VFX that you want to create. This works also okayish with animated stuff, but after a while you get real big problems if you want to interact in a more complex way. I have in my video game in Dashcap Kickers, I have a thing called Super Shot, and there you have a character. After loading up some energy, you basically can shoot, then the time stops, it gives the opponent some time, and then this huge shot is basically executed with a lot of VFX. And also, you see on the left side there's a bar that is going down. This is the opponent's energy that it can be used to super save the super shot. So it will be interrupted basically if the opponent is able to do this. And there we're coming into an area where it's hard to animate this. You can of course try to just interrupt it, and this would work. I tried it also, but whenever you change anything, you have to reanimate everything. So this gets really hard on iteration, and you have really to think out everything before, and it's not that fun on iteration-wise. So how would you develop sequenceable VFX, where you basically have things that can interrupt, and they don't not only perform something on time, but maybe by user input? Yeah, and the solution is a sequence action. And with the sequence action, I mean an action that has a variable end. So you're not only triggering it so that it does something, but you have also a function that can end it. So you can dispatch events or signals where you know, okay, it started and then it ended. As an example, you probably know all these things. You can use delays for that. So in the super shot, I have a delay for until the user can input some opponent anti-measurements. And also flashing is a very common thing where you just want to flash a character for a specific time. Also, the classic thing is just shaking something so that you have some visual feedback that there was a hit or something. Yeah, so those make sense to have. So you have not only something that it gets immediately, but has also an ending. But then you have a problem with an action list. If you execute everything immediately, then essentially everything runs in parallel. So this is a problem. You could now change the action list, or you just keep it. And then I decided for keeping the action list for immediate actions, but add two new types of containers that can execute actions and sequence actions. There's one called sequence, which will just execute any action or sequence action in sequence one by one, or parallel, which will allow you to execute everything immediately at once, but then it will wait until the first or the last sequence action that basically finished. If you know asynchronous programming from several languages, you probably know this pattern. It is like resolving promises basically on a node level. So now we can add an on-def example for the enemy. And so it references a new sequence called on-def. And sorry, you can see here on def, basically when it's hitting it, you disable the physics And then at the same time, you play the death particles, the death sound, a white flash, a VFX, a big shake, and then you wait until it's done. After it's done, because now the enemy is dead, you just wait for a little bit so you don't get into concurrency issues or whatever can happen to your logic, and then you basically clean up the node and remove it from the node tree. So what are actions actually now? If I have to do some marketing terms, I would use signals tell, actions do. More formal, they are basically serializable, composable, sequenceable functions that you can use to orchestrate VFX, but also other effects like audio or even simple state changes for logic events, like something opens or something gets just changed. A very cool thing, what I just discovered over working with it for a couple of years is a lot of visual editing software that you get, especially for non-coders, is always in a graph. But graphs have a big problem, and they have no order. It may seem not that big of a problem, but if you have a team that works all together, this becomes a real problem because everybody is structuring their order in the graph totally different. Somebody from from top to bottom, somebody from left to right, and also what you have to do in most graph programs is you have to connect which one is the first one, which one is the second one, and also what I think is more annoying is like to always pass parameters and outputs to inputs and all that stuff. With this technique, that's why you put everything in the member into the members to have them as a parameters. They are basically, you don't have to arrange something like this. You still could do this if you want to. You can do like all the fancy references, but in the editing, you basically are free of that, or in the hierarchy editing. So also the cool thing is, what works pretty well in Godot is you can also just do this in the editor. So, and what I mean in the editor is you don't need to run this to actually check it out. So this makes all the editing without any new graphs that are overlaid over your scene. You can just do it directly in Godot. And you can do this by this function. It's called trigger action in editor. So every action that is created can be immediately tested in Godot. So I can try if this works. This is an example project that I did, which shows a lot of effects. And this is one where you change the season from spring to winter. And it's using a lot of things to change. It's changing the music. It's changing global shader variables and a lot of things. And I hope you can see it. It's not playing, but that's fine. So maybe you check that out on my website. We can also, what I want to show is basically some live examples where you can see how actually it works in editor when you can in real time just edit all your VFX stuff with all those actions all together. So I prepared a small scene where you can see something like very similar to the examples, and I called it here Electric Kid. And if I press trigger action in editor, you can see something is happening. And if you're not, somebody now that has to maintain it, you can just open it up and see, oh yeah, there's a shake, which you can trigger. There's a blue particles thing with, that are filled, something with outlines, then some sound, and the flash. And this goes on. This is, those are all examples of basically very static effects that you actually don't need sequencing, but you can also do something very complicated, like the on-death sequence, where you can arrange something like this. And as you saw, this was all in real time in the editor, and I can also go to all the separate things and just test them alone, like the repeating signal start, just the flash, or the whole explosion. Just a second. Yeah. There are a lot of VFX in there. I won't explain too much about them, but there's particles going on, post-processing effects, and all that stuff together. I can just quickly show, for instance, this is the shock wave, or this is the lens flare, and they are all basically all together. So yeah, this is the real-time editing. What I really like about this is like it communicates directly in the editor what you actually did, and it becomes quite important, I think, if you want to maintain a lot of projects, especially in a team. So when I developed Dash Cupcakers, I had another problem. It was not only like how do I develop those VFX, it's also like I had to implement replay, so everything you did had to be recorded and to replay it again for all these effects, and also it had to be working as a multiplayer as netcode. So you could do this with every function. You could just try to network every function. This is very, it makes a lot of fun to have this. Or you could just extend the action itself, so only one class. And in this one class, I basically implemented one RPC function that allowed me to set up the action. So you could just say, are you basically running only by the server? Are you owned by one client, or are you available to everybody? With this, every action that you basically write, and this is which is trivial, that means it has only static content and has no randomness, everything that you did will be immediately networkable. So you don't need to write any specific network code besides this one function for the action, where you just need to send the references and then the action will be triggered. And what is even more funnier is if you have such a sequence of actions, you basically don't need to sync any of those child actions. You can just sync the root node, and then everything will be networked. This technique is working quite well, and if you have something that is more complex, where you change references, in my framework I do it like this. There's one seed function for randomness that you can just call before you do the trigger stuff, and it will be generated if you are the sending part. If you are the receiving part, you just get what you received. Same with data. If you can just have some checkboxes for, oh, I want to transfer references and all that stuff, and then this will be automatically transferred. This allowed us in my former company to basically develop networked multiplayer VR experiences that we did for educational reasons, and like a lot of programs with universities, we developed network stuff in 1 or 2 weeks. So we just did a single player application and then took 1 or 2 weeks to make them multiplayer able. First problem of this is of course co-op multiplayer. This is not first person AAA FPS whatever multiplayer. So you would have a little bit of problems with cheating, but this is usually never a problem for somebody who's just creating a co-op multiplayer. But there are other problems with the technique. Usually what we did, also because we also started a lot with VR and XR stuff, we use a lot of the interactor and interactable pattern, where the main thing that you do is, because the nodes or the actions are made for having references, what you have to do is like figure out where the references are coming from. So either because you know the type, so something in interactor, something you maybe want to click, and in interactable, something that is clickable, that those work together in the pattern where the interactor figure out the interactable, and then the interactable has an action called onClick. And then this will be called. Maybe you also pass the interactor into the interactable while it's executing its function. This is the second part of the dynamic objects. This is also sometimes you have to do something where you change the references, and yeah, then you just have to do it. What we also sometimes did was generated actions automatically from bigger objects. Sometimes for logic objects, it's just easier to do this, like you have one function that actually modifies a state, and then you can just automatically create actions out of that. What is also problematic is sometimes, as you maybe can think now, this is like the opposite of the global event bus pattern. It is really forcing you, or not forcing, it gives you the ability to know directly what is happening when an event or a signal is happening. But you can still do the opposite. You can do global event buses where you say somebody will maybe take the action and you just call everybody or call every node in the scene that has a specific pattern. But I would avoid this because it's really, it has the same problem as global buses. You don't know who gets the signal, and you have to be very careful. Also, that was happening a lot with new programmers that we had in the team was they were too lazy to write code after a while because they liked the system so much. So they started to, because it is basically, if you write it correctly, it is Turing complete. So you can then write with those actions actually code. So people started to do this. They had some integers that could be modified and incremented and all that stuff. And that's not a good place to do it. You can do it, but it's just messing things a bit up. So yeah, the actions are really awesome for sequential VFX. I think for now this is the best solution for me to create all these complex effects in one very nice and speedy iterative way. You will have a great orchestration workflow, and it works very good in the Godot Editor. And what I like the most about it, it is actually for coders and non-coders. If you look on your code, if you use those actions, you will see that you will basically forcing yourself to only writing logic code and side effects code, so that you don't have all these, how do I play now particles and or sounds or whatever. It's basically very clean. Yeah, if you want to try the actions, if you don't like frameworks, which a lot of programmers don't like, it's very easy to write this on your own if you just want the basics. Like actions and action lists is probably something you can do in 1 hour, just like the interface is trivial, and then you just have to do something that iterates over an array and then reuse that. If you want to have it more complex, you can try out my library. I have a website, I have documentation tutorials, I have a Git repository, and I have a huge ecosystem, which is basically battle tested what we did in several projects. Like you can have something like a cooldown where you cannot retrigger an action after a specific timeline, or you have only something that can only happen once. I know this shouldn't be the solution, but dying should be only happening once. And we had this so much in our code that we just, okay, we need a once node. It's so important. Also, you can repeat stuff. You can trigger actions on ticks, time-based, or on process, frame-based. You can reference other actions, or you can reference other sequences. You can load scenes asynchronously. You can set a node state. You can do slow motion timeline speeds, tween particles or tween materials, which basically creates a delta between two materials, and will, in the state of tweening, will use only the delta material, and then in the end will use your end material. And then I have like a suite of 40 or more compositor VFX, and they are all tweenable, and yeah. So the future in the library will have also, because this is right now a C# library, which is for C# and GD script at the same time. There are also GD actions, where you can just write them without interacting with C# code. But there's also planned, because I'm working right now on a C# to GD script transpiler, that I have a library that has no C# at all, so it will be a GD script version only. And I'm also planning to have networking features and other stuff complete, also compositor features and more stuff. And also with Tiger together, we maybe plan to create a swarm examples with his ECS framework, which is basically, I think, a known thing from if you come from Unity or other frameworks. And yeah, this will be maybe showing how you can orchestrate big swarms with with the library. So yes, that was it. Thank you a lot for listening. Oh, and as you can maybe see, the QR code contains all the stuff. The slides are up there, the example, tutorial docs, and all are in the address or in the QR code. Any questions?
Thank you very much. Any questions?
Hi. Kind of the only real question I have is, like, is there any significant overhead on kind of doing this with nodes versus just doing it in, C# or GD script directly?
Yes, but it's very hard to tackle down the performance-wise because on one side you're reducing your code base because you don't have to repeat all that stuff, and it's also if you do something like streaming nodes, then this will be more performant than having to code that has to interact on ready, because this is one of the biggest bottlenecks that you have in streaming. And of course, it's one new class with a memory block that will have an impact on your performance, but it is usually event-driven, so if you're not using this to orchestrate 1 million nodes to do the same thing, which you shouldn't, then this will be probably not a big problem.
Hi, thank you for the talk and the great resource that I'm going to use.
Thank you.
But I was wondering there, in the player you showed this, or well, the capsule, you showed this post-processing effect. And does that mean that if I want to test these effects, I need like a post-processing node in every like scene? That doesn't seem practical. So I figure what's the trick behind the curtain there?
I'm not sure what you mean with the post-processing effect, but I can try to explain what actually happens with the compositor stuff, because that is the only post-processing that is going on. I have a resource called Compositor VFX, which gives you some options to how do you reference the compositor that you are actually going through. And it also allows you to mark a layer in I'm calling it compositor effects layer. That is basically an empty effect that you put in your compositor, and then the effect that you're triggering will search for this layer and put itself underneath it, so that you can have an order of your effects. This is quite important because you cannot just randomly push them on somewhere on the stack. But yeah, it needs a compositor to run. So if it won't find any compositor in the scene, it will not work. Yeah.
Okay, thanks. So no singletons.
Oh, a lot of singletons.
Oh, okay.
A lot of. It's C#, so it's really not a big problem. But it's really coming from the usually I try to give you the opportunity to directly references if you want to, or it will automatically try to check one of the cache singletons.
Okay, thanks.
All right, any other questions? Doesn't look like it. I have a question. You showed me the file order, and that's the order when the effects are going, right, from top to bottom. Is it also possible to make them randomized, so you can just put a couple of them in the same list and then randomize which one is going to play? Yeah. Okay, perfect.
Yeah, I didn't maybe this is one thing that is maybe more complex, but you can do it. And the thing is, when you have randomness, then you have the problem with networking, because you then have to synchronize your randomness. And one trick to do this without doing it actually is to have a thingy where the random node is not synchronized, but the random entities or the nodes beyond are actually synchronized. So yeah.